Good day and welcome to another physics lesson with Mr. Simons. Today I'm looking at grade 10 electricity. We're answering November 2022 Eastern Cape paper, right? So, in the circuit below, the connecting wires and battery has negligible resistance, right? Now 9.1. Okay, they gave us a circuit. The total voltage of the circuit there is 24 volts over my cells, batteries. There we have a 2 ohm resistor that's connected in series. And we have 24 and 8 ohms connected in parallel, and we have switch S that is open. Alright, 9.1, define the term resistance. 9.2, calculate the equivalent resistance of the resistors connected in parallel. Total resistance of the circuit. 9.2, when the switch S is closed, the voltmeter connected across the 2 ohm resistor measures 6 volts, so 6 of the 24 volts are used there. The remainder should be used in parallel. And 9.3, a charge of 18 coulombs flows through a battery in 6 seconds. Calculate the current in the 2 ohm resistor. So you may stop the video here and attempt to answer whatever you feel you know. See where you get stuck so that you can read to it and fix your errors. Right. So 9.1, define the term resistance. In short, it's simply the ratio of the potential difference across a resistor to the current in the resistor. So ratio between potential difference and current across a resistor, 2 marks. 9.2, calculate the equivalent resistance or the total resistance for those two then. So in short, should know 1 over R parallel equal 1 over 24 plus 1 over 8. But instead of using that, we've combined it into one equation. So I can say resistor 8 times resistor 24 divided by resistor 8 plus resistor 24. So basically when we add two fractions, we cross multiply and we add the denominators. So there, R8 times R24, 8 times 24, and the bottom 8 plus 24. Alright, if we simplify, that becomes 6 ohm. So when you say equivalent resistance, instead of using the two resistors, could have used one resistor of 6 ohm. Alright, and as you can see, in parallel, the more resistors we connect, the lower the resistance becomes. You'll see that's a question in some of the other exam questions. Right, so in parallel, the more resistors are connected, the lower the resistance becomes. Get the total resistance of the circuit. We take the equivalent resistance in parallel plus the resistance in series to get the total resistance. So RT, which is the resistance total, would then equal 2 plus 6, which then gives me a total resistance of 8 ohm. So put together there. So multiply the two resistors, add the two resistors, alright? And punch in your values you get. So that's equivalent and total resistance, alright? Now let's look at the other questions. Right, now when switch S is closed, voltmeter connected across the 2 ohm measures 6 volts. So we need to understand the following, very important. In parallel, voltage remains constant. In series, current remains constant, right? So whatever voltage I've used in series, that I have to take away from my total voltage to have the constant voltage in parallel. So I have 24 volts. Because voltage is constant, don't mean 24 volts goes to those two in parallel, because there must still be voltage left for the 2 ohm to use. 2 ohm use 6, therefore 24 minus the 6 gives me 18 volts that's used by both the 24 and the 8 ohm. So there 24 volts minus 6 volts gives me 18 volts, which is then used across the parallel combination. Right, 9.3. Charge of 18 coulomb flows through the battery in 6 seconds. So I've given you charge and I've given you time. Calculate the current in the 2 ohm resistor for 3 marks. So first mark we give you is for selecting the correct equation. Charge equal to I times the change in time, 1 mark. My charge is 18 coulomb. My time, 6 seconds. So second mark for correct substitution. 18 divided by 6 then gives me 3 amperes of current in the 2 ohm resistor. Right, so I hope you follow, you understand. Make sure you know where we allocate marks and for what we allocate marks. Wish you nothing but the best. Continue practicing. The more problems you do, the better you'll become. More past exam papers you work through, the more you come to understand the pattern the examiners follow to test and catch you out in the exam. God bless. Bye.